Hi, folks, and welcome to Open. Fuck off, Jesko. It's going to be hard to do.
I'll keep my hands off the controls for now.
Hi, folks, and welcome to Open Analysis Live. So today, something a little different. I'm feeling under the weather, as you guys can hear. Don't worry, it's not coronavirus, just a head cold. I'm vaccinated. I take vitamin D, listen to Joe Rogan. That should be good. So instead of me doing this tutorial, I brought along Jesko here, who I used to work with. And he's going to demo a really cool framework set of tools that he's developed to help quickly triage binaries. It's kind of like, I guess the best way to think of it is like CyberChef, only CyberChef you can use quickly from the command line. So if you guys like that tool, I'd say stick around and learn a little bit more about Binary Refinery. So I guess with that, you could explain how you see this tool, how to install it, and how to get started, Jesko.
Okay, hello. So I think the description was pretty good. It even says so in the README when I say here. The project was born to aid with malware triage and is an attempt to implement something like CyberChef on the command line. If you don't know CyberChef, I think Sergey has used it quite a few times already. It's basically if you have binary data and you want to perform transformations on it, you can chain a bunch of those together to go from, well, some binary blob that you find in a malware to something useful that you actually want to look at. I have to do this all the time because I mostly do first assessment and like in simple cases end-to-end analysis. But usually what I want to do is I have malware and there's binary data in it, a configuration or a payload or something, and then you do some reverse engineering, you understand how the unpacking or decryption or whatever it is happens, and then you want to implement that, or you want to reproduce that fairly quickly. And so what most people I know end up doing is either use things like CyberChef, which is nice and all, but it's not really quick, not really snappy, not really fast. You can't. It's not a command line tool. Or you start writing Python scripts, obviously. And I wanted something in between. I wanted something that is faster than writing a Python script in terms of development, but also, well, I wanted exactly this. I wanted a bunch of command line scripts or tools that you can chain together with Unix piping operators to to replicate certain transformations on binary data. This is the GitHub page, so it's on GitHub. I am not a software engineer, but I try to apply some common sense to the development. So I have tests and stuff, and it's not broken all the time, but it is continuous integration, and things break. But I also fix bugs because I use this every day in my job, and if I do reverse engineering for fun, I use this. So it is maintained, and it is and bugs are fixed, which is, I think, a good thing. Okay, enough chit chat.
How do we get this shit installed, Jesko?
Yeah, how do we get this shit installed? Blah blah. There is a the README should tell you. There's several ways to do it. Essentially, it's just on pip on the Python package index. You can install it with pip. You can install it from the index, which will install the most recent version, or you can install an editable package directly from the repository, which is what I will do. I did already install it, but Sergey told me I should probably show how to install it. Stop hijacking my mouse. The easiest way to do this is to just get the Git repo, clone it locally, and then run an update script. So I will be a little slow on this command line because while I do use Windows, I would usually have a better shell than the built-in one. There is a script called update.ps1 and update.sh, update.ps1. Or if you want, open the script and go through the steps yourself in an editor. The main thing, if you install this and you want to play around with it, I think my recommendation is to create a Python virtual environment. It's a way to limit, to install all the this package and all its dependencies into an isolated environment, so it doesn't screw up your system Python installation. because it has a lot of dependencies and well, I mean, yeah, I wouldn't want you to shoot your system install. So now you can see Python waging war on the forces of dependency hell. I mean, I want to do like there's a lot of things you might want to do with binary data during malware analysis. So I'm depending on a lot of external libraries. I very, very much try to keep it pure Python, like don't have any dependencies that will break. I run unit tests on Mac, Linux, and Windows, so it should always work. But you know, it's on GitHub. You can open issues if nothing works. Right. So now it is installed. It is installed into this virtual environment, and I could just. I mean, it works a little different on Linux than on Windows when you want to activate a virtual environment. Oh, I should use proper backslashes. I think this is how it works. So yeah, and now there will be a bunch of commands. One is hex, which does hex decoding, but there's also AES, which does AES, or I don't know. There's DN fields, which extracts fields from .NET binaries. The complete documentation is on the website, and it's super retro. Looks like this. On the right-hand side, you see all the commands that exist, which are quite a few. There's a ton of crypto. There's some decompression, hashing. I don't know. Basically, whenever I have something that I can't do, I write a new unit, is what I call them, and we'll push the change. So, and if you ever run across something that you can't do with Refinery, I am extremely happy about feature requests, requests for new units, and pull requests even if you want. All right, if you install Binary Refinery, there will be one command that I'm probably showcasing for the first time here, which is binref. So if you run binref, it will do a full text search on all units that exist, which can be pretty useful if you want to do something and you don't know if it already exists. So it's I searched for B64 for base 64, which found quite a few units and printed out their help string. The help string is the main documentation for all of these commands. So, right. When you want to use the toolkit, I think one way is to, like, after having installed it into a virtual environment, you can just activate the environment and work inside that environment. What I do on Windows is I add the scripts folder of the virtual environment to my global path variable, so I can use the scripts everywhere. One way to do it. Another way to do it, which many people who I showed this to prefer, is that you set the environment variable refinery prefix before installing it, which this will lead to an installation where every command is prefixed by whatever prefix you chose. You will figure it out. Okay. Or Sergey, I guess. And anything I should explain, anything that is like completely confusing at this point.
No, I mean, I think anybody who's using this is going to be at least somewhat of a reverse engineer. I think your install instructions are probably like some of the easiest I've seen for these tools. So don't sweat it. Good. I'm pretty sure everyone can get this set up. The main thing is just that, like, even though it's written in Python, these are scripts that you call directly from the command line.
Yes.
So any way that you would set up your tools so that you can call them from the command line, you need to do the same thing here. That's basically the only thing to keep in mind.
Right. So I'm going to make the prompt a little smaller because there's going to be a lot of commands on it. It is not just a bunch of scripts. There are a few, I would say, like, there's 3 pretty unique concepts to how the tools work. And I recently wrote a tutorial, which is on the website. And I think I want to walk through the sample from this tutorial live, so we can. It'll probably not be the same as this tutorial, but I think it's a nice sample to showcase what is going on. So I hope it is here. Okay, so one unit that I very frequently use is emit. It's kind of like, if you're a Unix guy, it's kind of like cat. So it's just a way to output data. So it usually is the beginning of a pipeline. I will not get into how it is different from cat, but it is a little different from cat. The other thing I use all the time is the unit peek, which will just give me a peek at the data that is inside.
So that's like your hex dump equivalent, right?
Yeah, it's a little cooler than a hex dump, because this looks like text data, and I can also dump it as text. And right, I mean, this is some kind of PowerShell. We could dump it all, which would probably just be a bunch of, okay, so we're looking at, apparently it is a PowerShell loader, which contains these arrays where something has been encoded as arrays of integer literals. And you could read all the slightly obfuscated PowerShell code, or you could just try to extract the payload, because that's probably what matters. Let's do that. I think the one unit, I mean, the tutorial is good in the sense that it highlights the units that I find that I use most of the time. So one unit I really use a ton is carve. Carve does, I hope, what it says. It is supposed to carve patches of certain data from the input buffer. There's a few formats that it supports. You can carve integer, like a single integer. If you don't know why that would be a format, you would have to look at horribly obfuscated autoit droppers. Apparently I allow carving floats and strings. What we find interesting is the int array format, because that is exactly, and I will add the -s flag, which says I just want to carve a single one. So this carves out, well, with the -s flag, and I'll get to carving more than one thing later, but with the -s flag, it just carves the biggest chunk of integer array that it can find. Now, what do you want to do with this integer array? You would like to convert it to whatever byte sequence it actually represents. The unit for that is pack, which is is inspired by, is it Python terminology?
I believe it's the opposite of struct. So you'd be unpacking, right? Instead of hacking.
Maybe.
But yeah,
well, but so
same idea.
A common name, but a common naming convention in Refinery is that units are actually named after the operation that they decode. So I think I'm fine.
That makes sense.
So I'm going to peek the result, and it will. I mean, it will. You can see so FD. Now it's a hex dump. Now it's actually actual binary data, and the trained eye immediately notices that there is a bunch of B0 bytes in this buffer. So and
XOR encoding.
and the trained reverse engineer, oh, come on, wants to XOR this with this repeatedly occurring byte, and what comes out is a PE file. So nice. What you want to do at this point, most likely, is dump it to a file. I'm just gonna, so it's a DLL. I'm not gonna do too much at once.
Jesko can tell it's a DLL by just looking at the hex string.
Oh wow, this directory is full of other samples. But down here you see the payload DLL. What you would do now, of course, is reverse engineer it and find out that it's Netwalker ransomware. But we're not going to do that. I want to showcase the toolkit a little more. So you can't see it here because I have so many potential candidates in this folder, but the payload is very small compared to the PowerShell file, even if you account for the blowup that comes from the encoding. So you suspect, or you just look at the file and you realize, well, there's two buffers in it. And this leads me to the first thing that Refinery does that is probably not super common for most other toolkits. It can operate on more than one input and more than one output, and it has a fancy special syntax for that. So I want to carve now, this time, I want to carve only the longest buffers, and I want to take 2 of them. So this is LT2. You can read the help string to understand how this works. Int arrays. And if I were to pipe this simply to peak, what Refinery will do, it will carve these 2 buffers. It will separate them by new lines, because separating multiple outputs by new lines is a sort of de facto standard. But what you might also do is you could add an open bracket at the end of, like, it's an argument to the carve command. At the end of this carve command, you can an open bracket, and you can add a closing bracket as the it has to be the final argument of the unit. You can add a closing bracket here, which symbolizes that this peak command will operate on each of the output chunks individually. So it is a way to process multiple chunks separately.
So this is just a pause for a sec. This is where we start to get big brain on CyberChef. So this is where we start to really take advantage of having a custom tool, because obviously you can't do this kind of stuff in CyberChef, right? So
not that I know.
Yeah, not that I mean, maybe there's some angry guys like, you can totally do it. You just have to click a million times on the GUI. But like
I don't want to assume. I don't use CyberChef a lot. I have to be honest. I'm using this. So
yeah, but anyway, this is what makes this so powerful, is you don't have to actually write code with like for loops and stuff to jump through each like operation. You can do it all parallel.
Of course, you can do more than one thing to each chunk. So in this case, we pack each of the buffers and then peak each of the buffers. And oh no, it looks like they are encrypted with a different key, each of them. So the one up here is encrypted with the hex bytes 47, and the one down here is encrypted with the hex byte B0. Now, in the tutorial, I first explain at length how to dump them individually. The way you would dump them is you just do like this, or there's fancy syntax in dump that allows you to do this, which will do pretty much what you expect. It will insert the index of the current chunk at this position, so you will dump. But I mean, these are all things for a later tutorial. I will run straight to the next important feature that Refinery has, which is I call them multi-bin arguments. Every argument that you, or at least the arguments that you give to a unit that represent binary data, like for example, the argument to emit is a file name. Now, every argument that you pass to a Refinery unit that is supposed to represent some kind of binary data is usually in multi-bin format. And multi-bin format is, I mean, sounds fancy, but it's nothing fancy. It is a sequence of prefixes that allow you to make some kind of change the meaning of what comes after, and then something at the end, which is like a final piece of information. So if I do XOR, let's say Jesko, XOR Jesko, this would just represent, oh, this is not going to go well. I should peek this. So if I just XOR with Jesko, it will interpret this as the UTF-8 string Jesko and XOR the thing with that string. Okay. What I could also do, however, I could write this, which will not XOR the buffer with the string copy :3, but instead it will go to position 3 in the input buffer, copy the byte from that position, and use that as the value of this expression. So There are, if you now you can't, now you might be worried about, oh my God, there's weird magic going on with these prefixes. The one prefix that will make you safe and sound is S:, because S: says everything after this is just to be interpreted as a string. The other thing many of my fellow reverse engineers really like is the H prefix, which says anything following this is just hexadecimal encoding. So just H:, put something in hex and you're safe. It will not be, there will not be any weird interpretation. But these prefixes can be fairly powerful. For example, like there's a few prefixes that they're all documented in the, so I'll go to the documentation really quick. If you're curious, in the handlers that exist, they are documented in the arc formats part of the library. So there's the S and the H I already showed you. You can prefix with file if you want to make sure that it's data from a file. What I showed, the other thing I showed is the copy one, which copies input, which copies bytes from the input chunk. There's also the cut handler, which doesn't only copy bytes from the input, but it removes them from the input after that. And there's a few others that are like really weird and intricate. But more importantly, every refinery unit can also be used as a prefix. And for example, so how did we, let me rewind for a bit. Pack peak, come on. So this is what we were looking at. It's Python, so it's a little slow. It's not slow enough for me to implement it in another language, but it's okay. What led us to believe that the upper one is encrypted with 47 and the lower one is encrypted with B0? Well, we think it's an executable, and executables have a lot of 0 bytes, and we think that when we see a byte repeating a bunch of times, it might be the key. So there is a unit called DRP for detect repeating patterns, which is doing that. It tries to detect repeating patterns. So we could even more precisely say, okay, so we think that these are encrypted with a single byte XOR. So let's detect the repeating pattern of, let's say, the first 100 bytes. Now I get to finally explain the syntax a little more. The copy handler will receive as its final argument a Python slice syntax. So this is like, if this was like in a Python array access, you would recognize this as a slice. And I'm saying, please take the first OX100. This is why there are 2 colons here. It's just the first colon belongs to the handler and the second colon is just part of the slice syntax. Maybe this makes it less weird to look at. And now,
if you're a fan of Perl, you're going to love Binary Refinery.
The file name, directory name, or volume label syntax is incorrect. What did I do?
And
oh, I know what I did. Yeah, so when you do this, you should still tell it what to do, namely to XOR. Okay, and so this is a proper formulation of what we actually did. We looked at like the first 256 bytes, like copied them out of the buffer. We found the one thing that was repeating in it, and we XORed with it. So now you have 2 payloads, and we can dump them both to disk. I will do the full fancy schmancy syntax. Boom. Now, fast forward to the point where you have reverse engineered the payload and you know how its config is stored. I actually don't know it by heart, but it is so trivial in the case of Netwalker that I'll probably find my way. I will probably find my way to decrypt the config. So it's the same in both files, and it is stored in a resource, if I'm not mistaken. So there's tons of units for all kinds of formats, like, of course, specifically for PE files. And the unit to get PE resources is PERC. So they're all very Yeah, they're very short, and I mean, I have documentation, so I'm sorry. Apparently, this binary has only one resource, which is elite.
Suspicious.
Suspicious, to say the least. You could usually, when you have more than one resource, the PERC unit accepts like wildcard commands. Like you could specify which one you want, and then pass it to some other unit. But in this case, you could also just because there's only one, and I want to keep my command line short, you can also just do this. It will be the same, because if you don't give it any filters, it will just extract all of the resources, separate them by new lines, obviously, because I didn't use any framing. This would be formally more correct, but there's only one, so I can do this, is what I'm saying. There is this 05000 at the beginning, which makes me think this is the length of maybe a key. Okay. The next unit I'm using is snip, so I'm just removing the first 4 bytes. Again, Python slice syntax. I specify what I want to have. I want to have everything after the 4th byte. So I will peek a lot, so it's not too confusing. So this will give us everything here, and it's always, most of the time, it's either XOR or RC4. I'm gonna try RC4. And the key, I expect, will be the first 5 bytes. I have no idea if this is correct.
Those of you who have watched our recent videos, you'll see there's a common theme throughout most malware.
I got lucky. I mean, I wrote the tutorial, so I remembered. But yeah, RC4 is a big thing, and
key length and RC4.
But this is a different malware. It's not Warzone. It's Netwalker. But okay, so out comes something that looks like JSON. I have sometimes I implement units that are that serve no immediate benefit, like pretty print JSON. Yeah,
hey, pretty print JSON. That makes sense. There's a command I can get behind.
I mean, sometimes you need it. Okay, so this is the config, but one thing I would like to use this as a showcase, because I also do it in the tutorial, is the concept of variables, because Binary Refinery. So Binary Refinery has the whole the framing thing. That's the square brackets, which allows you to and oh, by the way, I didn't mention this, but you can nest them arbitrarily deep. So you can have like an arbitrary tree of computations that you do with this. It has the multi-bin thing, where you can, like, with the arguments to your units, can be complex expressions in themselves. And the last thing that is really useful when you do a little more complicated stuff is variables. Usually whenever you do any of the advanced things with Refinery, it's better to be inside a frame, which is how I call this thing, like inside the square brackets, specifically because what does this really do, honestly? When you add an open bracket to the end of the command, it just means that it will output its output will be in a specific in a binary refinery specific serialized format, and all the refinery units that come after it, they understand this format, so they can work on the chunks individually. And the next thing you want to do, as soon as you have your own serial format, you want to add metadata to it, which is also the next thing I did. So what we could do is we could we can make this less dependent on the, I mean, in this case, I snipped 4 bytes, and I had seen that the first 4 bytes were encoding the number 5, so I hard coded the 5. But we can turn this into like almost a decoder by saying I want to read the first 4 bytes as an integer and store it inside a variable. And there's several ways about how to store a variable inside a refinery chunk, but I will present the unit that is probably most straightforward, which is called put. It just puts a variable somewhere. I'm going to put the variable k, because why use meaningful words when you can save command line space. And what I want is the little endian interpretation of the first 4 bytes. So let's see how that looks. What has happened is it has the X thing is a shortcut for cut. Sorry, I usually save space all the time, but this is the same. So cut is a handler that works like copy, except that it will literally cut the slice that you're asking for out of the input buffer. So when we peek this before the put, we see that it has the 0500 thingy here. And after that is it has taken out these bytes and has converted them to a variable, which is called K. You can also see that it like the PERC unit has added its own, like some of the units add their own variables to chunks, like the path, which you may or may not want to use. Well, there's more to be talked about in future tutorials. Anyway, now that you have a variable attached to your chunk, you can use it. For example, you could say RC4 and cut not the first 5, but the first K many bytes. And then maybe pretty print this and show me 30 lines. And there you go. So this is like this is, I mean, I guess this is a self-contained config decoder for Netwalker payloads, which is kind of neat.
And if you guys have been paying attention to these tweets from whenever we tweet out a new video, you'll see this random dude on Twitter will often post a tweet below saying, "I did all of that work in one line."
Yeah, I have a I have a social media strategy. I lurk for other InfoSec people to do a lot of hard work and reverse engineering, figure out like how to decode a config, and then I just swoop and I'm like, you can do that in one line in Refinery. I mean, come on.
So all those gists that we post of like 40 lines of config extractor, it's like one line in Binary Refinery.
I want to caveat this. I personally fall into the trap of wanting to do everything in Refinery, even if some things are not worth doing like this. Some things really warrant that you write your own script. My solution for that is that you can write a custom Refinery unit. So I think I have some documentation in this super nice retro thing. Where is it? Right here. Okay, so writing a Refinery unit, if the module is installed, is fairly straightforward. You just write a class with a name you inherit from unit, and then you write a single function that is called process, which gets a single argument that is called data, and you do your thing and return the data. Why would you want to do that? Because if you write your own Refinery unit, you can still use it inside this whole framed syntax thing, and your arguments can be variables that have been extracted by other Refinery units. And I don't have a tutorial about how to write custom units yet, but it's in the docs and it's fairly straightforward. And I guess I just want to caution people, sometimes it's better to write some Python code, but many things can be done like this. And I try to improve it more and more and add more stuff. Do you want me to do some more? Yep, go.
No, that seems like a good place to sort of end for today. I mean, I think that's anybody who's seen this for the first time, like the first time I saw this, it was just like, ah. So I'm sure we'll leave it there for now. I think so Jesko already mentioned in his Git repository, there is a really nice tutorial where all of this is laid out in a Jupyter notebook. So you can basically copy the code over and use it yourself if you want. It's well done. I guess you'll show here on the screen.
I'll show, and I should thank you for giving me the idea, because I wasn't that, so it has a README and everything. I wasn't a huge Jupyter fan before I saw your video, and then I was like, oh, this is kind of cool.
The fact that it renders on GitHub is pretty awesome.
And for me, it has one other advantage, because this tutorial has, so I added some dark magic so that I can basically, I will not go into it. Anyway, I can recompile this. I can recompile this tutorial. Sometimes I change something about units, and I'm always worried that when I write a tutorial and 7 versions down the line, basically the output from the actual code would look different than what is in the tutorial. So I would have to go back and fix the tutorial. But this tutorial, I just rerun it, and the output is literally the exact thing that you would see if you ran the commands yourself. So
yeah, it's awesome. I can't get enough of it. Ever since the first time I saw it on stream, I was like, oh my God, this is genius.
Yeah, so thank you. It's it's very good.
So for those of you who want to basically give this a shot, I'd say this is probably the best place to start. Go to the GitHub, find the tutorials. It's under like /tutorials, and give this a try. It has everything from installation to doing that, walking through that example that we just showed here today.
And if I can make one request, please post issues and feature requests and stuff. If you're reverse engineering malware and stuff, just tell me, man, I found this weird algorithm. Could you please implement it? I would love to. I love adding stuff to it. Pull requests welcome, obviously. So yeah.
And do you want to give a shout out to like your blog and the training that you're doing? I think that's also pretty awesome.
Oh yeah, I mean, I can if I
think you should. I mean, honestly, especially for, I know a lot of you who watch this channel don't, you prefer Ghidra, Hail Hydra, and over IDA. And Jesko and Lars have this amazing blog and some training where they basically do a lot of stuff that we're showing in our channel, only they're using Ghidra.
Yeah, so it's we made this website. It is under mal.re, so Mallory basically for malware reverse engineering. And yeah, so this is me in this super serious photo of mine, and this is Lars. And yeah, we offer trainings using Ghidra mostly, almost primarily. I mean, we can do dynamic analysis and stuff, but that's obviously lame. Binary static reverse engineering is all the rage.
Static is the only accepted way.
Exactly. And we have a blog. It's not as easy to. Actually, you can type ntf.sh.
Oh, I'll also link all these below the video, so don't worry about having to copy off the screen or whatever. I highly recommend it, especially if you guys want to use tools other than IDA. I think it's probably one of the best blogs out there. But yeah,
don't say that. Pressure.
Oh yeah. All right, now it's getting awkward. I'll cut this out.
Say the tagline.
Until next week, keep exposing the mechanics behind the malware. Stay curious.
I'm sorry. I don't know it by heart. Should I say it?
Yeah, you should say it. Say it.
I don't know it by heart. You have to dictate it to me, and then you can cut out all the crap.
So you say until
stay curious. Until next week.
Stay curious.
Stay curious.
And keep exposing keep exposing the mechanics behind the malware. And stay curious.
Okay, so one more. One more time. Until next week, keep exposing the mechanics behind the malware and stay curious.
Stay curious, yeah.
Okay, so should we say it together?
Sure. And with
this
that,
will be hard.
Until next week.
No. You have to start up and with that, and then I can enter.
Okay. And with that, until
next week, keep exposing the mechanics behind the malware and
stay curious. All right, whatever. We're done. We'll see you next week.
Okay.
Yeah, you know you fucking feel me. Yeah, you know you fucking feel me. Yeah, you know you fucking feel me, right?